In this video, we are going to talk about sum and difference identities. First, we must remember some formulas. For sine, we have two formulas. Sine A plus B is equal to sine A cosine B plus cosine A sine B. And sine A minus B is equal to sine A cosine B minus cosine A sine B. An easier way to remember these formulas is to remember the acronym sin, cos, cos, sin. For cosine, we have two formulas again. Cosine A plus B is equal to cosine A cosine B minus sine A sine B. And cosine A minus B is equal to cosine A cosine B plus sine A sine B. Again, an acronym for this is cos, cos, sin, sin. And for tangent, we have tangent A plus B is equal to tangent A plus tangent B all over 1 minus tangent A tangent B. And tangent A minus B is equal to tangent A minus tangent B all over 1 plus tangent A tangent B. So once we have memorized these formulas, we are ready to proceed to our exercises. For our first example, we have to prove the identity cosine x plus y plus cosine x minus y is equal to 2 cosine x cosine y. We have two choices. We can either use the left hand side or the right hand side. But based from the given, we can see that it is easier to convert the left hand side. So we will do just that. So cosine x plus y is equal to cosine x cosine y minus sine x sine y. And cosine x minus y is equal to cosine x cosine y plus sine x sine y. This given is exactly as I have discussed in the previous formula, so it is just easy. So equals 2 cosine x cosine y. What we need to do is we still have to simplify the left hand side so that it will look like the right hand side. As we can see, we can cancel out the term with sine x sine y there. So what is left will be cosine x cosine y plus cosine x cosine y is equal to 2 cosine x cosine y. From here we can see that we have already solved the problem. 2 cosine x cosine y is equal to 2 cosine x cosine y. For our next example, we have to prove the identity 1 minus tangent x tangent y is equal to cosine x plus y over cosine x cosine y. From the given, it seems that the right hand side is easier to convert, so we'll do just that. So cosine x plus cosine y is again a sum identity, so we can write it as cosine x cosine y minus sine x sine y. Then we copy the other parts. From here, you can see that in the right hand side we can separate the term into fractions. So yeah, it will be 1 minus tangent x tangent y is equal to cosine x cosine y over cosine x cosine y minus sine x sine y over cosine x cosine y. So the first term, the first fractional term, is equal to 1. And the second term, we can still split it up into two fractions again. So 1 minus tangent x tangent y is equal to 1 minus sine x over cosine x times sine y over cosine y. We all know that sine x over cosine x is equal to tangent x, and sine y over cosine y is equal to tangent y. So we have solved the problem. 1 minus tangent x tangent y is equal to 1 minus tangent x tangent y. For our third example, we must prove the identity cosine x plus y times cosine x minus y is equal to cosine squared x minus sine squared y. So we will choose to use the left hand side. So cosine x plus y is just a sum identity, so it's equal to cosine x cosine y minus sine x sine y. And cosine x minus y is equal to cosine x cosine y plus sine x sine y. And this is equal to cosine squared x minus sine squared y. If you look at the left hand side, you can see that this is a special product and it is a difference of two squares. So we simplify the left hand side and we get cosine squared x times cosine squared y minus sine squared x times sine squared y is equal to cosine squared x minus sine squared y. The next step here is to use the Pythagorean identities. We can convert cosine squared y to 1 minus sine squared y and sine squared x to 1 minus cosine squared x. So doing so, we get the following equation, and from this we distribute the terms. So the resulting equation would be cosine squared x minus sine squared y, cosine squared x minus sine squared y plus sine squared y cosine squared x is equal to cosine squared x minus sine squared y. From this we can see that we can cancel out the term sine squared y, cosine squared x, and what we're left with is cosine squared x minus sine squared y, which is the right hand side. So we have solved the problem. For our fourth example, we will solve a different kind of problem. We are asked to find the value of cosine 15. Naturally, we won't be able to know the answer, but using the sum and difference identities, we will be able to know the answer. So cosine 15 is just the same as cosine 60 minus 45. And this is just a difference identity for cosine. So this is equal to cosine 60 cosine 45 plus sine 60 sine 45. We know that the value of cosine 60 is 1/2 and cosine 45 is equal to square root of 2 over 2. Sine 60 is equal to square root of 3 over 2 and sine 45 is equal to square root of 2 over 2. So simplifying, we get square root of 2 plus square root of 6 over 4. The next problem is also a different type of problem. Given sine A is equal to -4/5 and A is on quadrant 3, cotangent B is equal to -12/5 and it is in quadrant 2. Find sine A plus B. What we're gonna do here is we need to find the value of sine A plus B. So sine A plus B is equal to sine A cosine B plus cosine A sine B. We know the value of sine A, but we don't know the rest, cosine B, cosine A, and sine B. So we have to find the three values first before we can solve the problem. From the given, we know that cotangent B is equal to -12/5 and it is in quadrant 2. So let us remember that cotangent B is equal to x over y and cosine B is equal to x over r. But what exactly is the value of x? Because we only know the magnitude to be 12, but we do not know the sign. So let us notice that cotangent B is in quadrant 2, and if it is in quadrant 2, the x value must be negative and the y value must be positive. So we now know that x is equal to -12 and y is the positive one, is equal to +5. Solving for r using the Pythagorean theorem, we get 13. So the value of cosine B now is equal to -12 over 13. And we also need the value of sine B. Well, sine B is just equal to y over r, and it is equal to 5 over 13. For the next one, we know that sine A is equal to -4/5 and it is located in quadrant 3. What we need to know is the value of cosine A, which is equal to x over r. We are given sine A, which is y over r, but we need to know which one is positive. So we go back to the rectangular coordinate system. In the third quadrant, the x value is also negative and the y value is also negative. So your y here is equal to -4 and your x is also -3. Your r is equal to 5. By the way, you can get x using the Pythagorean theorem. We can now solve for the value of cosine A, which is just equal to x over r, which is equal to -3 over 5. Now that we have solved for the three values, we can now have the final answer for sine A plus B, which is just equal to sine A cosine B plus cosine A sine B. Sine A, which is equal to negative 4/5, cosine B, negative 12 over 13, cosine A, negative 3 over 5, and sine B, 5 over 13. Simplifying this, we get 48 over 65 minus 15 over 65, which yields 33 over 65.